Hello, good morning, and welcome. Today's webinar is on AI disruption in action. Intelligence will change the way we work. And today's webinar is presented by the good people at AI Works by Works Applications. Works Applications is actually a Japanese ERP software developer from Tokyo, Japan. They have over a 50% market share in the ERP and HR market there, and they are well known in Japan for developing the best artificial intelligence tools today. Speaking with us today will be Afshin Nahid, Senior Manager, Client Solutions at AI Works by Works Applications, and Brian Nakajima, AI Product Specialist, also from AI Works by Works Applications. And I'll go ahead and hand it over to Mr. Nahid now, and he'll take us through our presentation today.
Thank you, Rich. So as Rich mentioned, my name is Afshin, and I am part of the team here at AI Works. And we thank everyone for joining us today. So in this webinar, we're going to cover some interesting topics and ideas that will maybe make you rethink what you know about artificial intelligence and the impact that it could have on our lives and how our lives could potentially change. So I want to start off our discussion today by talking about the idea of disruptive innovations. So Sebastian Thrun is one of the thought leaders around technology and artificial intelligence. And he was also one of the founders of the Google X Labs, which was the company that created the Google Glasses technology. So recently he said, things are changing rapidly. A lot of things such as planes, phones, and clothes that we see today and use are all old inventions from 150 years ago. In the next 50 years, 99% of those existing things will be replaced by new innovations that are being researched and developed right now. So to me, this is really interesting. So 99% of the things we use today are going to be replaced with things that we are researching and developing today. So if we think about that, there's already tons of examples of this happening right now. So, there's a lot of disruptive innovations and advancements happening within the transportation industry, for example, specifically, let's say, in trains. So over time, we've had advancements from the standard steam locomotives to electric trains and bullet trains. And today, there's a ton of research and testing going on to make our existing train systems even better and faster with the invention of the Hyperloop. So the Hyperloop is supposed to make long-distance travel by train much quicker by using innovative technology. So they basically use some sort of magnetic force to reduce air pressure and wind resistance and basically push a train through this tube at what they're hoping for, up to 750 miles an hour. So they're still testing this. And we're going to see our transportation systems advance, very quickly with innovations such as this. We've also seen a lot of disruption in the aerospace industry recently with the idea of reusable rockets. So just last week or the week before, SpaceX was able to launch their Falcon Heavy rocket into space and actually have two of the rockets come back to Earth and actually land. And those will actually be reused for future missions. This is a pretty big deal because this is going to significantly reduce the cost of space travel, which will basically allow us as a human race to make great advances in what we can achieve within the aerospace industry. And this type of disruption, it's really great, and it leads to tons of cool possibilities that we've never had before. For example, something like this, the Starman that got sent up in the Falcon Heavy. I'm sure most of you guys have seen this picture, but for those of you who haven't, this is not a photoshopped picture. This is a real car that was sent into space and is going to be floating around for, nobody really knows how long, but maybe the next billion years. So this is, a direct result of disruptive innovations that are happening. We've seen huge disruptions in the customer shopping experience also. So before, in the quote-unquote olden days, if we needed laundry detergent, for example, we had to get in our car, go to the store, take out our wallets, pay for it, and then bring it home. As time kind of progressed, we created technology that helped us make that experience a little bit easier. So instead of needing to get in our car and go buy something, we could just get on our computers or our phones and order it online and have it show up at our door within a few days. So now companies like Amazon have taken this a step further. So we don't even need to take the time to go on our computers anymore to order something. I'm sure most of you have heard of Alexa or Google Home or Siri. These are all basically digital assistants. So now we say, hey Alexa, buy laundry detergent. Or even better, we can push a button that is connected to our washing machines that is communicating with our Alexa or Google Home, and it automatically orders the laundry detergent for us, and it'll show up at your door, maybe even in 2 hours. This is another really amazing form of disruptive innovations that we're seeing, and new tools like this are coming out all the time. Another place we are seeing disruptive technology and disruptive innovations is in the shipping warehouses. So what you see in this picture is a set of robots that have completely changed the way warehouses and the fulfillment process works. So if you think about how items are normally shipped and processed from a warehouse, the employee would basically get a list of items that are supposed to be shipped to a customer. Then they would have to go find each item at the designated spot within the warehouse. And then they would basically take them off the shelves and then pack them and then ship them off to a customer. So Amazon has figured out how to increase the automation levels within their warehouses to basically produce the maximum amount of efficiency for each employee. And they had to do this because they were getting so big and they were getting so many orders that they could barely keep up with the demand. So basically they had to innovate. So I want you guys to take a look at this video. This shows how operations work within an Amazon shipping warehouse. What you see here is, an example of an employee that is loading items into a categorized storage bin. And interestingly, what she's doing is actually replenishing stock on inventory. And these items are taken to the employee by these patented robot systems. The entire warehouse is wired for these robots to move back and forth and take employees who are basically staying in a stationary position. These pods are delivered to the employee at the exact right time for the employee to pick the item out and to go into the customer shipment. So rather than an employee walking around a warehouse, searching for the correct item, it's actually brought directly to them at their workstation. So Amazon was able to cut down the fill order on some items from 90 minutes to just 15 by implementing these robots around the warehouse. So not only have companies like Amazon brought disruptive technology to the consumer with their Alexa systems, for example, they're also using these innovations themselves to help their business processes and make things more efficient. So another example of where we're seeing disruption is in the automotive industry. More and more manufacturers are developing autonomous driving technology, which is, a great example of how AI is being used to not only transform our lives, but also transform business. So I want to show you guys another video of a fully autonomous car that is actually on the streets. So take a look at this video of Tesla, which is basically in fully autonomous mode. It's really important to point out that the driver here is not doing anything at all. He's not touching the wheel. He's not touching turn signals or the gas or brake. And also, this is not a test track. This is a live environment that this car is basically in self-driving mode. Basically, what he did is he inputted a destination into the car's GPS, and everything was handled by the car on its own. So what you see on the right side is actually the view of the camera systems that are used on the car. The cameras and sensors that are being used help guide the car. It helps read speed limits. It detects other cars and people. And it really monitors everything that's important for self-driving to occur. It's really amazing to see this in action. Another important thing to point out about these camera systems is that in addition to providing guidance for the car, it's also recording and saving tons and tons of data that's used within the Tesla network for all the other Tesla cars that are on the road. That's a lot of data. So analysts at Morgan Stanley have predicted that there's going to be as many as 3 million Teslas on the road by 2023. Each of these cars are going to be collecting data, which will in turn help Tesla fine-tune their machine learning technology, which of course is a big part of the self-driving technology. So a question that's been asked a lot is, what exactly is the car monitoring and what data is it collecting? So the car pretty much monitors everything. They keep track of speed limits. They keep track of construction zones. Supposedly they monitor things like potholes in the road. So if it sees that drivers are always swerving a bit in a specific point in the road, it knows that they may need to avoid that pothole if possible. And then when they're in self-driving mode, it'll automatically avoid that pothole for the driver. And, the more and more data that gets stored, the better the experience will be for the drivers. So I want to stay on this idea of self-driving cars for a bit, because this is something that we've likely all heard of and maybe even experienced. So this is happening with all major car manufacturers. Brands and manufacturers like BMW, Mercedes, Audi are investing pretty heavily in self-driving technology. So, what does that mean, and what impact is that going to have, and what is that going to really change? At first thought, people, would come to the logical conclusion that if other manufacturers don't get on board and start investing in this type of technology, they may become obsolete and basically get crushed by their competition, which is true. So if Honda and GM don't come out with self-driving features in their car, and all the other manufacturers do, there's a really good chance that they won't make it in the industry. No one will buy their cars, and they're always going to want the latest technology. So yes, in that respect, the landscape of auto manufacturers could potentially change with this new innovation of self-driving cars. But there's a much deeper or more significant effect that could come from self-driving cars. outside of just the automotive industry. So, let's take a look at some of the business opportunities and changes that could result from this idea of self-driving cars. So, in the US, we spend about 750 hours a year driving. That averages out to be, about 2 hours per day that we're in our cars driving, which is pretty significant. So let's take a look at the impact that artificial intelligence and self-driving cars will have on, let's say, these stats. So currently, 90% of auto accidents are actually caused by some sort of human error. Everything from speeding to falling asleep while you're driving, of course, drinking and driving. These are all human errors that cause a lot of accidents. One of the impacts with self-driving cars will be drastically reducing the amount of human error while you're driving. So we still have a ways to go for this, but for example, imagine if someone fell asleep at the wheel and the car automatically took over and took them home, for example. Or if there were no more drunk driving fatalities. What we want to do is look at the impact that this will have on other industries. So let's take a look at insurance, for example. If 90% of accidents could be eliminated, what would happen with insurance rates? Do you think they should stay the same? Do you think they should go down? Should age matter, or the car you're driving? Should that affect your insurance rates? Also think about, the impact that it could potentially have on body shops and car repair industry. If no one's getting into accidents anymore, how is that going to affect the body shop industry? How are they going to make money? Another interesting fact, in relation to accident rates is, the majority of emergency room patients have some sort of auto-related injury. What if those patients disappeared? How is that going to affect the medical industry? Will there be less doctors that are needed? Will they have more time to spend on other, medical matters? So this idea of self-driving cars, really has this trickle-down effect outside of just the automotive industry. It has the potential to affect several different industries. Let's take a look at another example. So currently in the U.S., personal vehicles have about a 5 to 10% utilization rate. There were, I think, 236 million vehicles registered in the U.S. in 2016. The majority of time, these personal vehicles are either parked or when they're at home or people are at work. So they're not being used very much. With the advancements in self-driving technology, what could that change? So imagine if you could make money by signing your car up for an autonomous rideshare program. So when you are at home sleeping or you're at work, your car is out Ubering people around, and you're making money when you're not using it. Also, in relation to that, what type of impact could lower ownership and higher utilization rates have on, let's say, the planet? There's a big push towards electric vehicles, of course, but if we think a little further, what if we didn't need to produce as many vehicles? What if we didn't need to produce as much rubber for all of those cars, or as many batteries, or all the little plastic parts and leather and whatever else is needed to make a car? This is all possible with the introduction of self-driving cars. Let's take a look at one other example. So in relation to the idea of using your car for a rideshare program, when you're not using it, think of the impact that could have. So, this is another example of the trickle-down effect that could happen. So the idea of self-driving cars creates the ability for you to sign your car up for a rideshare program. If you use your car for a rideshare program, then you won't have as many people that need parking spots, for example. So, you can think about how is that going to change the architecture of how cities are built in the future? Is there going to be a need for as many parking lots to be built at shopping centers, at sports stadiums, or even the companies that own these parking lots, like Ace Parking or a similar company? These are all things that will be impacted by the expansion and the innovations behind self-driving cars. So, think about your own personal life too. If you had 2 hours more per day to do, different things instead of driving, what would you do? Most people are going to consume more media. They're going to read more books. We're going to educate ourselves more. We're going to be more productive and efficient with meetings. So for sure, all of these things are going to happen, which will create an impact on different industries. There will be more demand for media and entertainment, for example. People will be able to get 2 hours worth of work done before even showing up to the office. The medical industry is going to change with less auto accidents and less people being admitted to the ER. And all of this is a result of what we're calling disruptive innovations. So this disruption is really, really having a huge impact on business and different companies in the United States and around the world. We've seen a very short lifespan, for example, with companies of the S&P 500. So 52% of companies have disappeared in the last 15 to 18 years or so. And also the average lifespan of these companies has shortened from 61 years to only 17. So, this shows that a lot of change and disruption is going on, and that if companies keep up with some of these disruptive technologies that we just spoke about, there's a good chance that they won't make it and their company won't survive. So, disruption is not always something easy to see coming, or even to notice while it's happening. There's been a lot of, monumental underestimations of disruption in technology. Let's take a look at some examples and let's see if you guys can guess who has made these underestimations of different companies. So the first one is, Google is not a real company. It's a house of cards. Of course, this was proven to be very incorrect. This was said by Steve Ballmer, who at the time was the CEO of Microsoft. So another one was, $500. I said that's the most expensive phone in the world, and it doesn't appeal to business customers because it doesn't have a keyboard. iPhones will never sell. So again, this was a huge underestimation of disruption, and was again said by Steve Ballmer, who was the CEO of Microsoft at the time. So Netflix is not even on the radar screen in terms of competition, and we see now that Netflix is doing very, very well. And this was the CEO of, at the time, Blockbuster, which they have completely gone out of business. And then one of the last ones is, who listens to 1,000 songs? This was said by Ed Zander, who was the CEO of Motorola, and he was referring to the iPod Nano, thinking nobody would ever listen to 1,000 songs. So again, these are all very big underestimations of disruptive technologies and innovations that were going on, that while they were happening, people weren't recognizing the effect that they could potentially have. Innovations have been happening all around us, and we've touched on this a bit in the past few examples. But let's now take a little bit of a deeper look into artificial intelligence, which is really at the core at a lot of these disruptive innovations that we've been seeing lately. So artificial intelligence is not a new concept. It's been around since the late 1950s. The concept or phrase AI was first coined in the mid to late 1950s when a group of scientists got together at Dartmouth College and they had the Dartmouth Conference. So the proposal for this conference basically included the assumption that every aspect of learning or any feature of intelligence can be so precisely described that a machine can be made to simulate it. So they basically wanted to see if they can prove this to be true. And from that point forward, for the next 20 years or so, which was called the golden years of AI, there were different experiments done, there was different theories made. They had computers that were solving algebra problems, proving different theorems in geometry, and learning to speak different languages like English. So this was considered the first wave of AI. From 1974 till about 1980, there was a drastic slowdown in the progression that was being made. So this time period was called the first winter of AI, or the slowdown of AI. And the reason for this slowdown, there was a lot of different factors, but one of the key ones was the limited amount of computer power that was available during that time. There wasn't enough memory processing power to really accomplish anything that was particularly useful for people. So because of this lack of progress, funding for artificial intelligence projects started to disappear also. Then, around 1980, we saw another rise in what was called the expert system era. So expert systems are basically programs that could answer questions or solve problems about a very specific domain of knowledge. It used different logical rules that it basically was inputted from someone who knew about these different domains, so knowledge experts. And then again, from the 1980s till about the 90s, we saw what was called the second AI winter, which was, again, caused by many things, but partially was a lack of funding for AI projects because people didn't really believe that AI was the next big thing. And there was also system limitations also. So from the 90s on, we started seeing this explosion of growth in AI projects. There were supercomputers that were being built I think in 1997, there was a computer that beat the world champion chess player. There was a lot of self-driving car projects, innovations such as Siri and IBM Watson. And we're really still in this upward trend of AI innovation. And there's more and more companies that are really investing heavily in artificial intelligence and machine learning technology. So, why now? I want to quickly talk about why there has been so much talk about AI and machine learning, let's say in the past 10 years or so. So there's been this, perfect storm, you could call it, of technology that has really allowed AI to become feasible for us and something that is proven to be useful. And there's so many new AI innovations, just in the past few years. So it's a combination of three different things. It's the advances in internet technology and speeds and different devices that are becoming available, which basically is resulting in the creation of tons and tons of data. It's the increase in processing or computing power, specifically through cloud computing that has become available. And then third, there are a lot of newly developed algorithms designed very specifically for machine learning. So look at the first one. we are currently in a state of, what could be called data overload. The amount of data being produced and collected is increasing exponentially, and there is no real sign of this slowing down. Everything in our lives is becoming digitized, which basically means the creation of more and more data. So from digital ebooks to our personal information to sensor data, transactional logs. I mean, it's kind of an endless list of things that are becoming digitized. As an example, today we are uploading, 48 hours of videos to YouTube every single minute around the world. We are sending out 2 million tweets per day and uploading 75 million pictures every month to Facebook. So that is a lot of data, and this is all data which needs to be stored somewhere, and it needs to be accessible and manipulated. And the combined data, just to give you guys a reference point of how quickly data is growing, the combined data used up until the year 2000 was a little less than 12 exabytes. And now it's projected that, by 2020, we will be probably at 35 zettabytes. And that's a lot of data. And it's, again, going to keep growing and increasing over time. So the second aspect that has caused the, AI project to really explode has been the advancements in cloud and distributed process technology. So companies like Amazon and Google have had, they have such large storage centers, and they utilize something called distributed processing. And this is what has really allowed artificial intelligence to kind of flourish. So previously, companies would build these supercomputers that were very expensive, they were hard to maintain, and they were hard to repair. And now, with newer server technologies, companies can store huge amounts of data in a cloud environment, and they're able to manipulate that data on the fly for significantly cheaper than they were able to do it in the past. And this is really important to think about for artificial intelligence, because rather than having one system process or analyze or search through data, you can have multiple systems that are working together on different types of tasks. All right, so the last component of the perfect storm that I mentioned that has really allowed current AI projects to become possible is new machine learning algorithms that have been developed. And this is really at the core of the current AI wave that we're in. So in order to understand machine learning, let's take a look at an experiment that was done by Google. They wanted to see if a computer could basically learn what a cat was. And this was a really interesting experiment because if you think about it, how do we as humans understand what a cat is versus, let's say, what a dog is? When we're young and we see a cat, in a book or in real life, we get constant reinforcement from our parents or the text in the book or on the TV or whatever we're watching that, this animal is a cat or this animal is a dog. After seeing a cat enough times, we're able to tell the difference. But if you think about it, how do we actually do that? And if we break down what allows us to differentiate a cat from, let's say, a dog, the question came up: is this something that can be done by a computer? So when you show a picture of a cat or a dog or a goat or a rabbit or something, to a computer, how can it tell what it is? And what's interesting is that the way that this is done is it uses or it imitates the same type of reinforcements that we as humans got, and it kind of resembles how the human brain works. So The way Google did this was they had something called their DeepMind experiment, and they wanted to see if they could not only have a computer identify what a cat was when it was shown a picture, but actually be able to illustrate what it was. So what you see on the left is, or I'm sorry, on the right is an image that the Google computer was able to create after viewing thousands and thousands of images and videos of different cats. So the computer basically was doing something called feature extraction. And it was able to recognize different patterns and similar features in all the pictures and videos it saw. And then when it was asked, what is a cat, it created this illustration based on different things that it learned. So it picked up on the common features, which was, for example, pricked ears or pointy ears, straight whiskers, and there's a lot of different features that it noticed a commonality with all the pictures, and it was able to come up with this this image that you. So in order to do this, there's definitely a difference between a computer being programmed and a computer being trained or learning how to do something. And with that, I'm hand it off to Brian to go into a little bit more detail about how this is done. So Brian?
All right, thank you, Afshin. Now that we have gone over the basics of AI, let's talk about how AI's algorithm is fundamentally different from the conventional approach and how that is being applied to practical enterprise applications. One of the most important things that the Afshin also mentioned, things to understand when it comes to AI is that AI is a training-based algorithm rather than a conventional programming-based algorithm. So let me give you a quick example here. This is the Google's research on its AI called DeepMind. So I'm sure everyone knows this simple game of Breakout. So you move the bar on the bottom, on the left and right, to bounce off or to break those colorful blocks on the top. And then what you see on the screen is AI, not human, playing the game. And AI is only given only one mission, and that is to get the highest score shown on the left-hand top score in the shortest amount of time. And the only option that AI was given was to move the bar from the left to the right, and that's it. And at first, the AI does a pretty terrible job. It misses and drops the ball often, just if a human child plays the game for the first time. But after, watch what happens after the AI is trained for the 2 hours. So after 2 hours of training, AI already plays quite decently. And again, this is happening without any programming whatsoever. And while AI was moving the bar left and right randomly, it learned the instances when it did hit the ball back and broke the blocks successfully. And if you were to program this game, it would require a tremendous amount of coding if they were to approach this with the conventional programming base, because they would have to code every possible pattern. If the ball comes from this angle, the bar needs to move this way. If the ball comes from that angle, the bar has to move from this, and that would have been pretty impossible. However, let's look at what happens after 4 hours of training. And after 4 hours of training, the AI already plays this game like a pro. And watch what happens after right here. The AI kind of creates a tunnel at the on the side so that it can get a lot of scores in the shortest amount of time. And AI doesn't know the meaning of getting the highest score, or they don't get a fun out of playing this game. But while it was getting trained, it happened to create a hole on the side, and it scored a high score in a relatively short amount of time. And AI kind of learned, hey, if we make a hole on the left on the side, I can score a very high score very quickly. So let's. So another example or reason why AI has to be train based. So I'm sure this news of AI called AlphaGo defeated Go Master in recent years. So a machine has previously defeated a human in chess years ago. So why was this so significant? Well, it was significant because the conventional programming-based approach would never be able to do this due to complexity of the game of Go. So let me explain this what I mean. So as you can see on the screen, chess only has 10 to the 120th power patterns per match, but the Go has that of 10 to the 360 power patterns. So when the machine defeated a human in the chess years ago, programmer actually programmed every single possible pattern that could happen in the game of the chess using a supercomputer. But it would have been impossible to program a Go, which has a 10 to the 360th power. So just to give you an idea of how even a small number of increase in complexity can make the programming or calculating that much more difficult. Let me show you this table. So this table shows the correlation between number of letters in password and how long it would take to calculate the all the possible combination using a regular computer, not a supercomputer. So if you look at the 4-digit, if you create your password, 4-digit password using only 26 letters of alphabet, non-cap specific, your regular computer can calculate every possible combination within 3 seconds. But if you increase the number of digits of your password to 6 digits, only increase of 2 digits, that number of minutes increased to 37 minutes. So if you look at the table down the table and increase the possible patterns, let's say if you use a cap-specific alphabets and numbers, even only 4-digit password will take 2 minutes to crack it, and 6-digit will take 5 days to crack it. And if you look at the most bottom right-hand corner of the table, if you use a 10-digit password and use alphabet, numbers, and symbols, which has a 93 possible characters you can use, it takes almost 10 million years to calculate all the possible patterns. So if you go back to the case of the game of the chess and Go, so increasing the patterns by 240 zeros, so 10 to the 360 power patterns of the Go, it would have been impossible for the programmers to code for every single pattern that could happen in the game. So instead of the programming every single possible hand, what Google did was that because the Go keeps a record of all hands by both Go players, Google fed the thousands of past game records to AlphaGo. And Google also created AlphaGo 1 and AlphaGo 2 to make it constantly play against each other as much as 2,000 years worth in human time. So it became like a ultimate Go master. So no wonder the AlphaGo was able to defeat the human Go player. And this is just a side note, but the earlier mentioned increase in demand for massive computing power is what's driving the growth of companies like NVIDIA. It's the manufacturing of computing components suitable for large amount of calculation typically required by AI. So anyway, now let's talk about how AI or training-based algorithm is being applied to enterprise application. So this example, this startup company called Analytic was that they created an AI that is specialized in detecting lung cancer. So when showing X-rays of patients, this AI is able to detect whether the patients have or do not have lung cancer. And they can do that with 50% more accuracy than experienced human radiologist. The AI can detect the difference between the simple shade in the X-ray and the actual cancer cells without missing even a small spot. The greatest point they picked is that within just in the United States, there are 300 million X-rays of human lungs, and that is a great point to have because the AI have a lot of training data to learn from, and they're successfully be able to detect the feature of healthy lung and the lung with the cancer cells. Next example is the San Francisco Police Department using the AI to determine the patrol routes. So based on the past criminal records and incident reports that comes on daily, and other information such as traffic and the weather, the AI predicts the likelihood of occurrence of crime, and they will display that in the heat map you can see on the left-hand bottom. So every morning when the police comes into the station, the AI will tell the police, hey, this is the area where the crime will most likely happen. And then the police and the police department will strategically place a policeman and patrol vehicles around those areas. And if you see, if you look at the picture right next to the heat map on the left-hand bottom, and a circle with the red square, that is the actual places where the crime occurred. So AI, and if you look at it, AI actually successfully pretty good with predicting where the crime would happen. So this type of technology, police is using to strategically place their policemen to be more effective on police in the cities. And if any of you are looking at this and already going, aha, you must follow a tech news very closely. As you can see on the right-hand top of the screen, it is a U.S. Patent document submitted by Amazon back in 2013, and it is a patent for predictive delivery. So the idea behind this is when or right before you run out of, let's say, milk or deodorant, you open your window or door, and Amazon drone is already there waiting for you and asking, hey, I have delivered milk or deodorant for you. Would you like to purchase it? So what's making this possible is the massive purchase record that Amazon have. The Amazon is not randomly going down to every door and asking the residents if they want to purchase the milk, but based on your purchase history, past purchase history, or based on the location or your income level, and Amazon calculates the likelihood of person like you purchasing the product if the product was delivered right to the door. So when you can predict someone will purchase the product 80% of the time, let's say, it no longer becomes a gamble. It actually becomes a viable, profitable operation where you can calculate if the people purchase the product 80% of the time. You can calculate the cost it takes to run this operation and still comes out profitable in this operation. So what do the successful AI projects that have in common? Projects that I have already mentioned earlier is two things. The first thing is that all those projects focus on rather simple tasks. So maybe diagnosing a lung cancer and then applying a appropriate medicine might be a very, very high level thing to do, but separating X-ray scans of healthy lung and cancer cell is rather a simple task. And maybe operating operating a non fully automated warehouse might be a huge task to do, but delivering the product from one location to the next location, the shortest distance, is rather a very simple task. The second commonality that all those AI projects have is that all those projects have large amount of training data. So going back to the case of Analytic, so they did try to come up with the AI detecting other sorts of illness as well. Let's say stomach cancer or other rare type of illnesses. But however, those illnesses did not have enough training data to teach the AI to be able to detect the difference between healthy patients and ill patients. And again, in the lung cancer cases, only within the United States, there are over 300 million X-ray images within the U.S. So they had enough data to teach the AI and let them extract the features of a healthy lung and cancer lungs. So this is a summary of what we have gone over so far. So as long as you have a massive computing power and you have a new algorithm, machine learning, you apply that algorithm to the computing power, and then you have a massive training data. You can put that through those mechanisms, and AI is able to complete rather specific tasks, such as detecting cancer cells or detecting detecting cat out of the dogs. So is AI the solution for all the problems that's happening around the world today? And the answer is absolutely not. AI has a area where they excels, and there are areas that AI do not excel. And let's talk about where those areas are. In doing so, it is very important to understand what type of AI is out there. So all the AIs we have been talking about today is called the narrow AI or weak AI. So those AI are again designed to focus on rather specific tasks. And although a self-driving technology used by Tesla might look like a very broad tasks, but again, self-driving car AI is just simply a combination of several narrow AIs. And those narrow AIs function only based on past trends and patterns, and they extract the features out of the past data, and they will replicate for the future tasks. And on the right screen, what's called general AI is what you kind of see in the Hollywood movies. Maybe Ex Machina or iRobot, the AI that can do a task like they can do cooking, driving, and cleaning, all that. But the human are not there yet. The AI technology is not there yet, and all the AI we're dealing today is on the left, the narrow AI. So just to give you a very simple example of what narrow AI can and cannot do. So when you look at this picture, a human can tell this picture is a funny picture because a person like the former president of the United States, Barack Obama, is kind of playing a joke on this person who's weighing himself. So there's fundamentally something funny about a person with such a power in the world is playing a rather silly joke on another man. So we know kind of this picture is funny. However, so the AI cannot tell why this picture is funny. Maybe AI is able to tell this picture is funny based on the gentleman's mouth is kind of shaped upwards, or everybody's face muscles structures. Maybe they can tell this picture is something about funny, but they will not be able to tell why it is funny. So what can AI do? So AI can actually list the name with all the people pictured in the picture. When you upload a picture on the Facebook, Facebook can automatically detect who to tag on the picture because they have a vast amount of data, past data, hundreds and hundreds of pictures of you in before. So they will detect the features of your face, and then when the new picture is uploaded, they will apply data and say, hey, this person is probably you. So when AI looks at this picture, AI will a lot of us will can tell just the person in the middle is a Barack Obama, but you probably won't be able to tell who those people are in the back. But the narrow AI can probably list all the names, searching through all those past data. But again, what narrow AI cannot do is tell why this picture is funny. So finally, let's talk about how all those new technology with the AI will change how we work today. So just like the Afshin mentioned in the earlier part, Sebastian Thrun said 99% of things we use today will change in the next few years. And this does not exclude the things that we use on our work environment. So let me give you some examples of changes that are already taking places. So back in early 2000, the Goldman Sachs had over 600 traders on the Wall Street trading stocks every day. But today, there are only two people. Instead, given between 2000 and today, there was a 2008 stock market crash. But instead of those 600 stock traders today, they have 300 program engineers that are constantly improving their mechanism and algorithm for fast automatic trade programs. The second example is the AP Associates Press. Until recent, maybe 4 or 5 years, they were only able to produce 300 articles per day maximum. But today, they're producing more than 4,300 articles per day. So how are they able to do that? So before, a human, let's say, assistant editor would write up a draft, and then they will bring that to the chief editor and then get that approved. So everything was a human manually created. But today, the AI, based on the past thousands and thousands of past articles, AI will draft those articles, and then the chief editor will approve those articles. So what happens is that if you read today's articles out there, let's say earning calls, the government shutdown, the actual content is pretty much the same. So let's say the Dow dropped by 1,000 points, and this was the largest drop ever since X number of years. The AI can learn from the past articles, and it can quickly come up with they just fill in the blanks of Dow dropped with blank points today, and that big of a drop was ever since X number of years. So that work does not need to be a human work, and the AI does all that. So let me skip to the next one. So again, this is the not only on the work environment, but as Ashley mentioned earlier, so we already have a technology like Alexa, where you can ask, hey Alexa, what's the weather today, or what's the schedule for today? But what's going to happen pretty soon in the future is that you can tell Alexa, hey Alexa, we are cooking a meatball spaghetti today, so be prepared for it. And then Alexa will communicate with the refrigerator, and they will just say, they will make sure if you have a meat, tomato sauce, and pasta in the fridge, and if you only order ingredients that you're missing in the fridge. And within 2 hours, that whatever ingredients you're missing will be automatically delivered to your doorstep. So that's the future we're looking at. So that's the type of world we're trying to create in the work. That's the type of the world that we might see soon in the work environment as well. So it used to be the system was so inflexible, the human only had to adjust for the system. So the human would have told the system what to do, and the system will kind of output the very limited number of tasks. But now the AI-based system is becoming much more flexible and more space for vagueness. The system, the AI assistant can give you more suggestions or proactively complete tasks for you. The idea is the AI system is so flexible that you can tailor your system and to help you with the whatever task you at your hand. So with the advancement with the AI technology, the AI assistant will be able to assist everyone in their own ways. So currently, so based on our research, currently in the typical workforce, a person spends as much as 81% of their work on mundane routine tasks such as data entry, data edit, or searching for the data to be entered. So, and they're not able to spend enough time on more value-creating tasks such as communicating with your teammate, brainstorming the next big ideas, or making decisions on the critical issues. So what we predict is going to happen in the next 5 years is that AI will automate those routine tasks based on the past data and given specific roles. And the next one is that based on those past data, AI is able to give you a suggestion. Hey, maybe would you like to do this task this way? Or hey, I completed this task for you, so can you check it for me? So those automation of routine tasks and a proactive suggestion will happen in the next 5 years. But we're not yet there to where AI can give you a prediction or projection of the future. It's definitely coming maybe in 10 or 15 years, but not in.
Thank you, Brian, and thank you, Afshin. We've learned a lot today about artificial intelligence and how it's going to change our future. If you'd like to learn more, please visit our website at ai-works.us, or you can send us an email at info@aiworks.us. Thank you very much for attending, and we hope to see you at the next webinar.